definitions, the green salt is a coordination compound, which is a transitional metal cation which reacts with a charged or a neutral species. Also, you have a complex ion, which is a metal cation associated with a number of ligands via coordinate covalent bonds. Now, during week 1, you have the synthesis of the green salt, and this involves the ferric ammonium hexahydrate, which you have the molecular formula written right over here. You're going to take this through a series of steps, and you're going to end up with this molecular formula over here. And now what's interesting is that the iron is the only element that you have which you're going to put through the series of steps, and you're going to see in the end product. And now just for a little bit of terminology, you're going to have two states of this iron, the Fe2+, which is a ferrous state, and the Fe3+, which is the ferric state. So yeah, week 1 is a synthesis of the green salt, and now in week 2 you'll be doing a standardization of the potassium permanganate, and week 3 is going to be the analysis of the green salt that you made in week 1. Now there are many steps involved in the synthesis of the green salt. Here are the chemicals that will be used in the preparation. You will use 95% ethyl alcohol, 3 molar sulfuric acid, 1.8 molar potassium oxalate, 1 molar oxalic acid, and you should include all of these molarities in your lab notebook. You will also use hydrogen peroxide, which is in this black bag because it is sensitive to light, therefore it will decompose in the presence of light. And as your starting material, you will use ferrous ammonium sulfate hexahydrate. Now remember to be wearing your goggles and your gloves for your safety. Now the first step of this experiment is to weigh out about 10 grams of your starting material. Now these balances go out to 4 decimal places, so you should include all 4 decimal places in your lab notebooks. Now no one's asking you to get exactly 10 grams of the starting material, so you should get somewhere between 0.1 milligrams of the starting material.
Now add 15 drops of H2SO4 to 30 ml of distilled water. Then warm the solution and dissolve the sample. After the sample has dissolved, while stirring the solution, add 50 ml of oxalic acid. Once the precipitate has formed, heat the mixture nearly to boiling while stirring. Let it cool and settle. After the precipitate has settled, the liquid layer above the precipitate should be clear. Now gently pour off or decant as much of the liquid as possible. Disregard the liquid into a beaker and retain the solid precipitate. And to remove as much additional liquid, you want to use an eyedropper. You will need to heat about 30 ml of water to near boiling. Now add the almost boiling water to the precipitate in the beaker. Stir and allow the precipitate to resettle. You want to repeat the decantation of the washed liquid as before, and then finally wash the precipitate once again. To the beaker containing the washed precipitate, add 18 ml of saturated potassium oxalate. Then heat this mixture to about 40 to 45 degrees Celsius. Now, to maintain the temperature, place the beaker inside a larger beaker containing water at the same temperature. From a burette, slowly add 17 ml of hydrogen peroxide while stirring continuously. Remove the beaker from the warm water bath and then heat it until the mixture is almost boiling. Now add 9 ml of oxalic acid all at once. Continue adding oxalic acid dropwise while stirring until you have a clear solution. If you still have some precipitate after you have added a total of 15 ml of oxalic acid, filter the hot solution and discard the precipitate. Add about 20 ml of ethyl alcohol to the solution. If some crystallization has occurred, heat the solution gently under the hood until all crystals are redissolved. Now place your beaker in your desk and cover it with an inverted beaker of a larger size. Make sure to label the beaker with your name and lab section, and then save it for your next lab period.